Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem which says let f defined from this to this, okay, be a function. So, you have f of x as this. Consider the square region S. Okay, so this is from 0 to 1 on x and 0 to 1 on y. G is this way. Now, who is G? Means if y is bigger than f of x, be called as green region. Okay, and this is R. If y is smaller than f of x, it is red region. Okay, means below it is red, above it is green. LH. LH is again some line segment, horizontal line drawn at the height this. Then which of the following statements is are true? Let's check it out. So for that, first we have to break down, like we have to draw the graph. So as you know that this f of x is what? Cubic polynomial. So you know that if it is cubic polynomial and we have to draw the graph, and the leading coefficient is positive, so at minus infinity it will be minus infinity, at plus infinity it will be plus infinity. So your graph will look like this way, and we will have three zeros if it is real. Means we will have one, like behind this it is increasing, and between this point it is decreasing, and after this point again it is increasing. Okay, so let's try to draw the diagram, and we can find out these things by using application of differentiation as well. Okay, so let's try to draw the diagram first. So this is our y-axis, this is our x-axis. We have to draw till 1 cross 1. Okay, so first let's create the box. 1, 1, 1, 1. So we have created that box. This is 1 comma 0, this is 0 comma 0, this is 0 comma 1, and this is 1 comma 1. Okay, now let's try to draw the diagram. So let's find out the critical point. Critical points means it's a point at which graph will change its definition. So we get critical point by using first order differentiation. So we have f of x as this, x cubed by 3 minus x square plus 5 by 9x plus 17 by 36. Let's do the differentiation to find out the critical point. We will do dy by dx equals to 0 to get the critical point. Now this is 3x square, so 3 gone, we are left with x square minus 2x plus 5 by 9. So this is first order differentiation. So if we will equate it with 0, we will get the critical point. Let's do it. So we got 9x square 18x plus 5. Okay, so we got 9 5s are 45, 15 into 3 है ना. So we got 9x square 15x 3x 5 equal to 0, 3x minus 1 and 3x minus 5. So we got our critical point at 1 by 3 and 5 by 3. Now you know that your graph will start from minus infinity and you will have critical point at 1 by 3 So look at this. First critical point is at 1 by 3. Second critical point is at 5 by 3. So we don't need 5 by 3. We need only 1 by 3 because it is ranging in this row. Correct? And you know that from minus infinity to 1 by 3 it is increasing, then it is decreasing. So from 1 by 3 to 1 it will decrease. Okay, so suppose that it is 1 by 3. Suppose this is 1 by 3 comma 0, and we have to focus on x coordinate only. Okay, we need not to find out the value. So first find out f of 0. So who is f of 0? So you will substitute, you will replace x with 0 and you will get f of 0. So you got 17 by 36. So 17 by 36 is means what? It is slightly smaller than 0.5. So look at this. Suppose this is 17 by 36. Then f of 1. So f of 1 is what? 1 by 3 minus 1 plus 5 by 9 plus 17 by 36. So we got 36, 12, 36, 20, 17. So if you'll add these two things, it will become 32. Okay, so we have minus of 4. So minus of 4, so it is 11 by 13 by 36. Okay, so 13 by 36 is very small, है ना? Smaller than half only. So it is somewhere here. So it is 1 comma 13 by 36. You know that till 1 by 3 it will increase, and then after 1 by 3 it will decrease. So our graph will look like this. Okay, now let's write down something. So look at this. According to them, g is y greater than f of x, means above part is green. Okay, so this part is green. This is green part. Above f of x is green and below f of x is red. Okay, red part is below. This is red part. Now we are we have to find out the area of red region so that we can conclude. So for that, what we will do, we will integrate from 0 to 1, and then f of x, the upper curve is f of x only, no? So f of x minus 0. So who is f of x? F of x is x cube by 3 minus x square 5 by 9x 17 by 36 dx. Now let's do the integration. So it will become x power 4 by 12, x power 3 by 3, then 5x square by 18 plus 17x by 36. You know that if you'll substitute upper limit, we will have 1 only, and if you substitute lower limit, everything will become 0. So the main influence will be because of upper limit. So we have 1 by 12, 1 by 3, 5 by 18, 17 by 36. Okay, so you know that below is 36, LCM will be 36 only. 3, 12, 10, 17. So we got this situation. So we got 18 by 36. 18 by 36 is nothing but half. So this is very unique number. Okay, means if you'll observe the square block, the length is 1 and width is 1, so the area is 1 square unit. And if you will focus on red region, it is 1 by 2, and if you'll focus on green region, it will be 1 by 2. So this curve is dividing this square into two equal areas. Okay, now let's check the first part. So the first part is, wait, this line I will take as reference. Now the first we will check it out whether it is correct or wrong. There exists h belongs to 1 by 4. So 1 by 4 is somewhere here. Okay, this is 1 by 4, and then 2 by 3. 2 by 3 is 60% approximately. Okay, 2 by 3. So in this room there exists a line such that the area of the green region above LH, means above LH green, and below LH red. Okay, there exists H such that the area of the green region above the line LH is equal to the red line below LH. So they are comparing red and green. So look at this. So if you will focus over here, look at this. Green is very, like, above this green, it is not half, because half, if you'll consider the full green, it will become half. And if you'll focus here, the red part below this line, red is half, but above this line green is less. So same. Okay, now green is getting increased but red is getting reduced. Okay, so we will have no such thing where green will be equal to red. Okay, so this option holds false. Okay, so this option A is wrong. Now there exists H such that area of the red above. Okay, so above is red, red is above, and red above, and the area of the red region below, so below also red. Okay, so look at this part. So look at this, just focus over here, red above, red below. So look at this. So if you'll focus over here, you know here red above is smaller than red below. Okay, so look at this. Gradually if you'll observe, the red is being increased and the above red is increased, below red is decreased, and full red is what? Half. So somewhere it will divide itself into two equal parts. Okay, means 1/4 above, 1/4 below. So this option holds true. Okay, if you'll observe this, it is clear observation. Okay, now There exists H in this room such that the area of the red region above and green region below. So red above, green below are equal. Let's check it out. Look at this. The red is smaller, green is also smaller, means below you have to observe green. So if you'll focus over here, there is a chance that you may have this green and this green combines to get equal to red. Correct na? So there is a chance that it may be equal, and it is possible. So it is also true. Okay, so this is also true option. Option C is also correct. Now there exists an edge such that the area of the region green above and green below, it is like option B. Okay, so this is comparing green above, green below. Let's look at here. So if you'll observe, you know that over here at this point, above green is half, below green is nothing. So if you will increase, there will be some time where this will be divided into half, means 1/4. Like if you'll observe, look at here, look at this part. The length is what? The length of this thing is 1, and width is what? Width is 1 minus 2 by 3, means 1 by 3. Okay, so it will become 33%, है ना? There is a chance that you may end up having equal area. This is pure observation. Okay, not calculation is required, only this much of calculation is required, which we did earlier. I hope the idea is clear. So see you guys in next session of MathFlix.